All right, welcome to The Explainer. Today, we're going to tackle a big one, a 5-mark GCSE maths question. You know the type. It looks super intimidating at first glance. But trust me, once you see the strategy behind it, it all just clicks. So let's break this thing down step by step.
Okay, so here it is, question 18. Let's take a look. What we've got is a quadrilateral. But really, it's just two triangles stuck together, right? ABC and ACD. The deal is they give us the area of one, and we've got to find the area of the other. Now, the tricky part, they only share one side. And that right there is the key. Everything, and I mean everything, hinges on us finding the length of that shared side.
So, step 1. Our first job is to find the length of that side, AC. I like to think of it as a bridge. It's the only thing connecting what we know about triangle ABC to what we need to know about triangle ACD. If we can't build that bridge, we're stuck. Simple as that.
Okay, so we know the area of triangle ABC is 54 centimeters squared. Now, how do we use that to get the length of AC? It's kind of like we have the answer, and now we have to work backwards to find the question. It's a classic move in these kinds of problems. But wait, if you look at triangle ABC, we've got two angles, sure, but zero side lengths. So before we can even touch that area formula, we're going to need one more piece of the puzzle. And not missing piece, it's just the third angle. Super easy to find, but you can't skip it. We all know the angles in a triangle add up to 180, right? So a quick bit of subtraction, 180 minus 57 minus 48 gets us 75 degrees for angle BAC. Boom! Now we have all the angles for our first triangle.
All right, so now we need the right tool for the job. And to connect the area of a triangle with its sides and angles, there's really only one formula we're going to reach for. Yep, it's the classic area equals a half AB sine C. This little formula is basically the key that's going to unlock this whole thing.
Okay, now this is where things get a little bit clever. Normally, you use that formula to, find the area. But for a top-level question like this, you can actually use it backwards. By combining it with the sine rule, we can flip it on its head to find a side length from the area. And since we now have all three angles and the area, well, it's the perfect technique for this situation.
So here's the magic formula. You see it there in step 1. It's basically a mashup of the area rule and the sine rule, and it lets us get right to the side we want, AC. So from here, it's really just a plug-and-play situation. We take our numbers, the area of 54, and the sines of our three angles, and we carefully pop them into the formula.
And bam, there it is, our first big breakthrough. You punch all that into your calculator, take the square root, and you get the length of our bridge, AC. It comes out to about 11.21 centimeters. Now, pro tip, whatever that long number is on your calculator screen, don't round it yet. Just keep it there. We're going to need that full number for the next step to make sure our final answer is spot on.
Okay, so our bridge is built, we've got the length of AC. Now it's time to cross over to the other side of the problem. Let's get into step 2 and see how this all leads to the final answer.
So now that we have that length for AC, you know what? We can basically just forget about triangle ABC. Seriously, we've squeezed all the information we needed out of it, and it's all packed into that one number, the length of AC. From here on out, our entire focus is on triangle ACD.
Right, new triangle, new focus. Let's do a quick inventory. What do we actually know about triangle ACD? And what do we need to know to use our good old area formula?
Well, looking at the diagram, side AD is 17 centimeters. We just did all that work to find side AC, which is our 11.21 something. And here's the best part. The question just gives us the angle right between them, 35 degrees. That is the perfect side angle side setup. It's exactly what the area formula was made for.
And look what's back, our old friend, the area formula. But this time we're using it the normal way. We've got the two sides, we've got the angle in between. So we can just plug the numbers straight in and find the area. No fancy rearranging this time around. So let's do it. It's going to be 1/2 times 17 times, remember that long unrounded number we kept in the calculator for AC? We use that now, times the sine of 35 degrees.
You run that through the calculator, and it spits out 54.618 and a bunch of other numbers. Now, the question asks for the answer to 3 significant figures, so we round that off to a nice, clean 54.6. That's our final answer, 54.6 centimeters squared.
Okay, we have an answer, 54.6. We're feeling pretty good about it, but the job isn't done until we check it against the official mark scheme. So let's see how our method stacks up.
So if you look at a mark scheme, you'll see P marks for the process. Did you follow the right steps? And an A mark for the final accuracy. And yeah, it looks like we nailed all the process marks. We started the process to find AC, we finished it, we used that to find the area of the other triangle, check, check, check. But wait a minute, that final accuracy mark, that's where there's a little bit of a surprise.
Hold on. Look at this. The mark scheme says the answer should be in the range of 52.4 to 52.52. We got 54.6. That's not a rounding error. That's way off. So what happened? Well, the reason for this is actually a really interesting little story about this specific exam paper.
It turns out the exam board actually issued a correction for this question after it was printed. So the version of the question we just solved, the one on the original paper, was actually a bit different from the intended one. The corrected version swapped everything around. It gave the area of ACD as 54 and asked for the area of ABC instead. And if you solve that version, you get the 52.5 answer. So get this, both answers are technically correct. It just depends which version of the question you were looking at.
So what's the real lesson here? It's all about the strategy. It's about looking at a big, messy shape and breaking it down into smaller, manageable parts. It's about finding that bridge, that one key piece of information that connects the two halves of the problem. And, as we just saw, it's about always paying close attention to the details of the question you're given.
Look, at the end of the day, whether you got 54.6 or 52.5, that's just a number. The answer is just a number. The method, that's the skill. The logical process of breaking down a problem, figuring out the tools you need, and building a plan from start to finish, that's the thing you take with you. And it's a skill that'll help you solve any tough problem, not just in maths, but anywhere.